Hey guys, it's Jamie. I did my presentation on 3-act tasks because it's something that I find very interesting, and we're actually working on implementing more of these in our classroom currently. And just by doing this research, it has really opened up more possibilities for me, and I hope that it does the same for you because I've learned quite a bit. First thing, what is a 3-act task? So a 3-act task is a whole group mathematics task consisting of 3 distinct parts: an engaging and perplexing Act 1, an information and solution seeking Act 2, and a solution discussion and solution revealing Act 3. In layman's terms, it breaks a problem into 3 basic acts. First, you want to hook your students with a problem that intrigues them and makes them ask questions. Now note, this is not a word problem or a problem on paper. This is a real world problem where they come up with their own questions. Then it gets them to think about what knowledge they have gained in the past or what information they could possibly need to find the desired solution. Finally, it leads to some incredible discussion about how the solution is applicable and what it really means. Now, why did I choose this? First of all, I want to increase classroom engagement with my students, as following the same path day in and day out can become monotonous and dry. Now, I also want to encourage my students to work on critical thinking skills, which can be brought back to their daily lives. I also want my students to see the real world connections in math rather than just a problem on a page. And finally, I want my students to understand that there isn't just one right way to get an answer. Basically, this is what's best for students. I want my students to think on their own and work together to come to a solution. In taking ownership of a problem, they can better relate to the solution and see how it makes connections to mathematics and everyday life. Now, what research supports this method? First of all, I found a quote from 13.org, and that reads as follows. Constructivism says that people construct their own understanding and knowledge of the world through experiencing things and reflecting on those experiences. When we encounter something new, we have to reconcile it with our previous ideas and experience. Maybe changing that might change what we believe, or maybe discarding the new information is irrelevant. In any case, we are active creators of our own knowledge. So to do this, we have to ask questions, explore, and assess what we know. 3-act tasks are doing just that. They're getting students to explore, ask questions, and make connections with what they know. It takes the 8 mathematical practices from our standards and puts them to use. It also promotes a growth mindset, as students can enter 3-act tasks at all levels and are able to make mistakes and progress through them to refine their skills and gain their knowledge. This has been proven time and time again, not only with Dan Meyer implementing his own 3-act tasks in his own classrooms with students, but also other people implementing these 3-act tasks and watching students grow right before their eyes. Now, with the mathematics teaching practices, they were all applicable, but I really wanted to focus on these 5 here. So to implement tasks that promote reasoning and problem solving, you have to engage students in solving and discussing tasks that promote mathematical reasoning and problem solving and allow multiple entry points and varied solution strategies. 3-act tasks are all about classroom engagement. Students work together to determine the problem and find a way to solve it. They require multiple entry points, and there are always multiple yellow brick roads to get to the Emerald City, so one solution isn't always what we're looking for. To use and connect mathematical representations, you must make connections to deepen the mathematical understanding of concepts and procedures as tools instead of focusing on regurgitating them, so students can use their knowledge and apply it to the problem to come out with meaningful solutions, which leads into facilitating meaningful mathematical discourse. By making these connections with the problems, the solutions can have value and logic behind them, which help guide the students to ensure that they're on the right path. To do this, we also have to make sure we pose purposeful questions, as not just any question is going to lead students into the meaningful discussions that we're wanting and give them a desired result. Finally, I feel that 3-act tasks are centered around productive struggle. The students are engaged together to reach a solution to a question that they themselves have focused on. In doing this, they are choosing to use their own knowledge to arrive at a logical solution. Now, the mathematical practice standards were kind of addressed on an earlier slide. These standards are very prevalent in 3-act tasks. Students are working together to overcome obstacles and productively struggle to not only come up with a question when presented with a problem, but also to press on until a solution is reached. But also, these students are now able to logically think through their solution to see if it makes sense. In addition to this work, students are able to build off not only their previous knowledge, but also the knowledge of other students. They can reason through all presented solutions and rule out those that are unsuccessful, as well as make connections between those that are successful, since they might not all be the same. Now, productive versus unproductive. Teachers should have to focus, or teachers should have to have more of these productive beliefs in their classroom as opposed to the unproductive. In 3-act tasks, you're developing understanding of concepts and procedures by using them. In addition, the students are using them by choice instead of being told to, and this can help them make stronger relationships between the math and the problem. Students, when working together, can all produce different strategies to reach the same solution and can work with each other to make those connections. Through this time, the student will be making sense of the math while the teacher is asking thought-provoking questions and allowing students to struggle through different processes until they arrive at a successful one. Now, how will I use it? I have 3 main parts. I want to start slow, I want to implement occasionally, and then more frequently, and then I want to vary the reasons and the time that I use this. So basically, I want to make sure that I start off using this slowly. I don't want to jump in and turn the students off to productive struggling right away. If I try to do too much, it won't work like I want it to, or I won't put the effort in that I would like to, and it won't be as successful. I then want to make sure that we aren't doing this all the time in every class. I think there's still some value to learning some things the old-fashioned way, and if we do 3-act tasks every lesson, the students will grow tired of it. Finally, I want to vary why and when I use a 3-act task. Sometimes it might be to introduce a topic, sometimes it might be to review a chapter, sometimes it might even be just to get some application in. But the key is that I don't want to use it for only one method or all the time. Finally, there were a bunch of really good resources out there about 3-act tasks. Specifically, there were a lot of things promoted by Dan Meyer. One thing that I found really helpful was this 3-act task guide, because it kind of walked me through not only why it was helpful, but how I could implement it successfully.